Hey, I'd like you to pause the video and try this problem on your own on a dry erase board or scratch paper. You want to use a sum identity to find the exact value of the cosine of 7 pi over 12, showing all your work. And once you've tried that problem, go ahead and resume the video and we'll go over the answer together. Okay, so if we take a look at our unit circle with the special angles labeled, we've got a denominator of 12 in our problem that we're working with, so let's get that common denominator on our unit circle. So pi over 6 would be equivalent to 2 pi over 12. Pi over 4 is equivalent to 3 pi over 12. Then pi over 3 is 4 pi over 12. And we were looking for two special angles that would add to 7 pi over 12. Since 3 plus 4 is 7, we're going to use those two angles, 4 pi over 12 and 3 pi over 12. So we can rewrite the cosine of 7 pi over 12 as the cosine of the quantity 4 pi over 12 plus 3 pi over 12. And reducing those denominators, we can get our special angles then of pi over 3 plus pi over 4. Okay, now we're going to apply our cosine identity for the sum of two angles, and that's going to give us the cosine of A, which is pi over 3, times the cosine of B, and our angle B is pi over 4. And then recall that in the notation, cosine of A plus B, right, we're using the top operation here in the plus or minus, we're using the plus. That then means when we get to the minus plus, we must also use that top operation, right? So top goes with top. So the cosine of the quantity A plus B is equal to the cosine of A times the cosine of B, then minus the sine of A, and our angle A is pi over 3, times the sine of B, and our angle B is pi over 4. Okay, so in that step, we used the sum identity for cosine. Now we're going to substitute in the values for each of these trig expressions. So the cosine of pi over 3, that's looking for the x-coordinate at that angle, which is 1/2. Then we're going to multiply that times the cosine of pi over 4. That's the x-coordinate at pi over 4, which is square root of 2 over 2. Okay, that's minus the sine at pi over 3. That's the y-coordinate at pi over 3, root 3 over 2. And we multiply that times the sine of pi over 4, which is our y-coordinate at pi over 4. And that's a square root of 2 over 2. Okay, now we can simplify. So 1 times square root of 2 is the square root of 2. 2 times 2 is 4. Then square root of 3 times square root of 2 is the square root of 6. And 2 times 2 is 4. So subtracting these fractions, since we have a common denominator of 4, we subtract the numerator to get square root of 2 minus square root of 6, and then that's all over our common denominator. And our exact value then is the square root of 2 minus the square root of 6, all divided by 4. We can check that in the calculator, making sure that we're in radian mode, which we are, by first evaluating the cosine of 7 pi over 12, and then comparing that to the answer that we just arrived at, which is the square root of 2. Oops, let's go back over there, minus the square root of 6, and that's all divided by 4. So when we compare the decimals, they're equivalent, which tells us that we did in fact find the exact value.